Can science explain telepathy, telekinesis, auras, or even ghosts? I think the science is here. Let's see what Joe thinks. Welcome to Truly Terrified, Paranormal versus Physics, where we talk about some really weird stuff, and Joe the scientist explains how it's not possible, or maybe it is. I'm Lynn, and...
I'm Joe.
Today, I'm talking about quantum entanglement, which is difficult because I do not understand it. I kind of think maybe there's a glimmer of understanding, but really I don't understand it. So it sounds like something out of a science fiction movie, but it's actually a real and super complicated idea in physics. It's often described as an invisible link between two particles, no matter how far apart they are. And you can interrupt, Joe, if you discover or hear me say something that is incorrect. So those two particles, no matter how far apart they are, when one changes, it instantly affects the other. Albert Einstein called it spooky action at a distance. But here's the thing. Thinking of it as spooky or magical isn't really accurate. It's more about how information is shared between particles, which doesn't really sound as cool. But it's closer to the truth. Even though everyone still talks about it as Einstein's spooky idea, especially after the scientists won the 2022 Nobel Prize for their work on it, and that's pretty recent. I didn't realize all this stuff was going on recently. It's just time to drop the spooky label. It just makes quantum entanglement even harder to understand. So, have I said anything that was incorrect?
No, not incorrect in the sense that of how most people understand it. So you not understanding it is extremely typical even for physicists. Nobody understands it. Anyone who says they understand it is lying because they can't understand it. We just don't have enough information about it.
A long time ago, when you were probably in your first or second year of college, you were trying to explain something to me, and I did not understand it. And so you used objects that I was familiar with in place of the terminology you were using. So I think that's valuable because when you use, not just you in particular, when science uses the word entanglement, we think about something that's like a ball of yarn that's all wrapped up together.
You can't really pull one part of it out without affecting
And my understanding is that's not really
it's just a word. You can kind of get a concept of entanglement, but describing it's one of those words where you either understand it or you don't. There's not really a partial understanding, which is problematic for conveying it. Okay,
so let's step into the paranormal realm here for a second.
Yeah.
When talking about quantum entanglement, the sense I'm getting, and of course I don't have an understanding of this, and I'm not educated in this in any way, shape, or form. I'm only going by, popular mechanics article I read, popular science, whatever it was. Couldn't that explain why people maybe can, like the episode we did last week on telepathy? Couldn't that explain that?
Well, so I have to say, there are some people that believe that maybe evolution or maybe whatever the human brain uses makes quantum mechanical measurements, for lack of a better word, quantum mechanical measurements, and is essentially doing that. It's getting, again, for lack of a better term, quantum mechanical information.
Yes.
By doing experiments on, itself and your blood, whatever. That's not technically outside the realm of possibility. That you are essentially gaining a particular type of information about a distant system, like another person, given that there was some common origin of that information. So it's packaged up, it's entangled, your brain does a measurement of it, and it tells you something about what that other person is also doing with that information.
Right. Okay, so there was an article this morning, and this was after I started reading about quantum entanglement, that, and I hadn't looked for it, just popped up in my feed, that is titled, it's from Popular Mechanics, and it's titled, Quantum Entanglement in Your Brain is What Generates Consciousness. Radical studies suggest.
I don't even know if I'd call it a study. It's an idea, and I guess there's some evidence that the microtubules, which are responsible for these quantum mechanical effects, that are throughout your entire body, there is some, again, for lack of a better word, quantum mechanical nature to their function in your body. So the idea is, I'm not exactly sure what they're supposed to do, but the microtubules that are in every cell of your body are doing something, quote unquote, quantum mechanical, and that is it. It's making you essentially somehow non-classical, where other things are classical.
Yes, it mentions, it says, although your brain is superior to your laptop or even the world's most advanced supercomputer, these machines run on classical physics, but there's another kind of computer out there, a quantum one. I actually looked up what a quantum computer was. And you probably know more about that. I'm sure you do. So this is what I found, is that quantum computers are advanced machines, and they use weird rules, the weird rules of quantum mechanics, to solve problems faster than regular computers. And I think it's unfair to call them weird rules. They're just different rules. They use special quantum properties like superposition, entanglement, and quantum interference to do calculations that today's supercomputers would take forever to complete. So who has quantum computers?
Who has quantum?
Where are quantum computers?
I think I'm not entirely sure. Like, I don't follow it very closely. I think maybe Google has the largest one, and it's like, I want to say like 128 qubits, which is a quantum bit, quote unquote. So various companies have them. As far as I know, they're still, I don't want to say controversial, but the benefit of using them is arguable, and people do argue for and against it. I don't know that they've been demonstrated to be generally useful.
What would be the argument against it? Do you know?
The people who really believe in quantum computers, as far as I understand.
You mean really believe in the value of them?
In the value of them.
Because they definitely exist.
Yeah. They definitely exist, yeah. Is that you'd be able to do things like run a classical program as a superposition and then solve it way faster on different time scales than a classical computer. So a classical computer would have to go through each solution and try it, and a quantum computer could do that. But there are people who argue that you can't do that. You can't solve classical problems with quantum computer. And there's, as far as I know, there's like certain properties of how physics actually works that really prevent you from getting out of your classical universe, essentially. I just don't know how to describe it that anybody could understand. So, but in all honesty, quantum computers are tremendously boring to me.
Really?
Yeah. The other aspects of quantum mechanics are much more interesting to me. I'd say about quantum computers, we're just not there yet. So
okay.
That's to be determined.
One of the reasons why I'm bringing it up is because it came up in multiple articles about quantum entanglement, referring to you would need a quantum computer to be able to figure things out. So I looked up what a quantum computer was, and it didn't say anything other than it's using these other methodology, but I don't know. It wasn't really clear to me. In case you're thinking that quantum entanglement is really, really bizarre and outside of our normal stuff that we're doing right now, the truth is that in China, they have a quantum encrypted communication satellite that relies on quantum entanglement between photons that are separated by thousands of kilometers. Back to the paranormal stuff. Could quantum entanglement, if our brains run on quantum entanglement, which is what that article said, my understanding, okay, correct me if I'm wrong, my understanding is at some point the particles have to have been adjacent to one another. And then they separate and they're no longer adjacent. And that creates the entanglement that they're still communicating.
Yeah. So there's one huge issue with the idea that that's happening between people. Something called quantum decoherence. So you can picture it kind of like heat. When you take a warm object, you take it out of the oven or whatever, and you set it on the counter, hopefully on a something so it won't melt the counter. It starts diffusing the heat away, and then it becomes the same temperature as the room. When you have an entangled system, you have to make sure it does not leak any of that information out. So it doesn't. See, here's the issue. When you entangle two objects and then you interact with one of them, you're extracting the information. You're decohering the entanglement, essentially. So when you touch it, when you look at it, when you do anything, you're breaking down the entanglement.
Oh.
So now imagine, it's not a carefully prepared system cooled to a few degrees Kelvin, and you're going to interact with it later. Imagine it's just room temperature, and there was all sorts of stuff. It's not a carefully prepared system. It's completely random. There's a huge problem. Picture it like this. What the world you see around you is what you're already entangled to. Okay? In order for two objects to be uniquely entangled, they can't be entangled with the world around you. So if you are trying to build like a model of how two people are interacting via quantum entanglement, they have to not be already entangled with the rest of the world. So how can you do that? So at some point they interact, they get entangled, they immediately are entangled then with the rest of the world. They cannot use that information.
That could explain why things are fleeting. It could explain why when somebody has a paranormal experience, it's a fleeting experience, and then it goes away. It's just fleeting. You just see something, or you just hear something.
So despite all of what we've just been talking about, there are a number of interpretations of what's going on behind the scenes in quantum mechanics. They're each models that have not yet been differentiated via experiment. Some of them have not been eliminated. They all give the same results based on what we've seen so far. And each interpretation is more or less comprehensible by people.
Okay.
One of them that just makes a lot of sense, but I don't necessarily believe it, but it really makes a lot of sense, is called the many worlds interpretation.
Oh, okay.
The many worlds interpretation is essentially saying that the world around you, there's a lot of different variants of what happens in the world. You're only seeing a very small part of the universe. Mm-hmm. And you're seeing a classical version of the universe, just one of many possible classical versions of the universe. The universe is much bigger than that. There's a thought experiment called Wigner's Friend that has, as far as I understand, now been experimentally, they've gotten experimental results, they've tested it, and either the many worlds, it's one of the things, like either the many worlds interpretation is correct, or there's superluminal information transfer, or superdeterminism. Again, if you don't like non-locality, i.e., superluminal information transfer, or you don't like superdeterminism, so you like having free will, if you assume those are not broken, then you have to go with something like the many worlds interpretation. Although the study I saw, as far as I know, wasn't peer reviewed. So, without a model of how entanglement actually works, we just can't say right now, yeah, entanglement is like, you're tuned in with the person at a distance and now you're transferring information or something.
Right. This is what I read. Quantum physics doesn't describe what reality is like. It only tells us what might happen when we do experiments to test our ideas about how the world works. It gives us probabilities for different outcomes, not a definite answer about what's really going on. The idea that quantum physics is explaining the actual nature of reality comes from the way physics has been taught for years, but that's not really how it works. Would you agree with that?
So I should say this. It's really important. Quantum mechanics works, the math behind quantum mechanics works really well at making predictions. Physicists do not care about just making predictions. They want to understand it. In order to have an understanding, you have to have a qualitative model. So not just a predictive model, but it's making an analogy between something you can comprehend in your brain and the universe. And so what we really want is a way to understand what's going on. We can make predictions, and that's why we even have the word entanglement. We make a prediction. Yeah, look, there's a statistical correlation when we do these experiments on these carefully prepared systems. But no one understands how that's possible. Now again, different interpretations say what's happening is different things are happening. So like the Copenhagen interpretation is, as far as I understand, saying there's probabilities that like a wave function, a matter wave, like you shoot an electron at a wall and it shoots off a matter wave in different directions, is actually a probability wave. And when you make a measurement, the probability wave completely is destroyed everywhere except one point. Many worlds interpretation, which is very popular, you shoot an electron at a wall and there's this wave that dissipates in all directions. And when you make a measurement, you're essentially displacing yourself into one of the possible different worlds that really exist, and you're now going down a different path than all the other possible ways the electron went. I mean, the electron's just everywhere, but you can just see one classical universe, essentially. The important thing about it all is, one, we just really do not know what's happening. Two, we can make really good predictions about what we'll see in statistically when we do carefully prepared experiments. Those, the carefully preparedness and the results we see in those systems breaks down completely when you go to larger scales. So when you get bigger, so like on a scale of a person, that all breaks down. That's what we call classical. We can't see those effects because we are classical, quote unquote classical. We behave classically. If you throw a ball, it's not a wave function as far as we can tell. But on a tiny scale, if I throw an electron, the next time I see the electron, it will have behaved weirdly. I will see a single electron, but it will have taken a path that would have been impossible if I just threw it like a ball. So that weird disparity is it should behave one way. We see it behaving a weird other way. When we do statistical experiments and aggregate the results statistically, it's very strange. This is very related, I think, to probably anything in physics, but quantum mechanics particularly. This is something I was thinking about the other day, and I think it's very applicable to quantum mechanics. Anytime you have something in the universe doing its thing, and it's evolving in time, it's changing in time, anytime you can look at that thing as it's changing and consistently relate it to some other information, and the other information's changing, and the thing is changing, if they change consistently, and you're looking at the thing consistently, you're relating it to the information consistently, if all of that's consistent, then the information is being simulated by the thing. And if the information is evolving, it can't see that it's in the thing because it's information inside of being coded on the thing, then it might not know that it's in a larger universe. So like I've given this example before, but I think it's a pretty good one. Imagine you have ants, and they're dancing around, they're ants. And they're not really thinking, they're just a physical phenomenon, you know. I mean, maybe ants do, but let's just go with it.
Okay.
They're dancing around, doing their thing. They're in this like waltz, ants waltz. And a person comes around and they see an image, this evolving image that the ants are forming, you know? It's like a scene that's being played out, like a play by the ants.
With their movements?
With their movements. You know, you can literally physically see, like, it's people walking around and talking and moving
They're
around.
Creating scenes with their bodies.
This huge collection of ants, it's arbitrarily large. They're dancing around, doing their ant thing based on whatever is in their ant brains. They're not really thinking about it. But the people, the shapes they're making are forming people. And, you know, you can take your microscope, you can look at the ants, the image of the brains the ants are forming, and you can see, yes, there's information encoded in these brains, which the ants are making the shape of. And as they're dancing around, the people that are made from the ants are moving and interacting and doing things, and those people are questioning what's going on around them. You know, they live in this world and they're interacting and going about their lives.
Not aware that they're just being images
simulated
created by ants.
So the ants are some physical process, and you can look, so that's the interpretation part. You can look at the image, the ants, you can look at the ants and you can see an image. The image is the information. And you can see as the ants are evolving like ants do, the information is evolving like it does. And the information is being simulated by the ants. So the people within the ants are being simulated by the ants. It's a completely natural phenomenon. It's not like simulation hypothesis or whatever. I mean, it is, but maybe the people inside the ants think one day, we're being simulated. You know, I wonder what kind of supercomputer we're being simulated by. But it's a natural phenomenon. You don't like substitute anything else for the ants. It's crystals in a giant cave, and there's electrical like sparks between them. And every once in a while, all the sparks line up and you get a new image, you know, like they color themselves or something. Or LEDs, like just random LEDs plugged into a circuit board, and there's just random firings. And every once in a while, they all synchronize, and a new image is formed. Doesn't matter how you get to the simulated universe. It just matters that they're consistent. As the thing evolves, the simulated universe evolves. But information can be contained in the simulated universe. As long as the outside physics evolves consistent with the inside physics, it's all good. You know, it all works. But the problem is, if a person is being simulated, let's go back to the ants to make it concrete. Okay. The people simulated by the ants don't know they're being simulated by ants. But they are developing models about what they see around them. The models are, the results that the models are predicting are also being simulated by the ants. So if you one day come in and flick an ant, you've changed that dynamic. Now the internal evolution of the system is no longer equivalent to the external evolution of the ants. The ants dance.
The ants dance.
And so you will see like a disturbance, a change that would not have been predicted by your models if you were one of those people simulated by the ants. So this is applicable to quantum mechanics, I think, because what we are seeing is stuff going on in our universe. But there are clearly problems that we're seeing with our models. It's really likely, like for instance with hidden variables theories, that there's other stuff going on that we can't see.
Yeah, I agree.
With the many worlds interpretation, there's other stuff going on. Other worlds, literally other versions of us, we can see a slice of it, but we can't see the larger picture.
I think it's really arrogant of us to think that, I don't mean you and I, but human beings, at any moment in time, for any one of anybody to think that they have an answer about anything.
Yeah.
I just think that's really arrogant.
So, to really just hammer this point home, it's really likely that we're only seeing it's like Flatlanders. Flatlanders are seeing a 2D plane, a part of a larger 3D or more D universe. What we're probably seeing, even with consideration quantum weirdness, what we're probably seeing is effects from our interaction with the larger universe. So, like tying in with paranormal stuff, yes, there could actually be, it's like a 3D being entering Flatland. That's a paranormal phenomenon.
Yep.
Flatlanders could not have predicted that. There are potentially, I don't want to get into like crazy quantum mysticism shit, but there could be ways people are inadvertently or deliberately manipulating their place in this larger universe without knowing it or with knowing it, and that's having coherent, like predictable effects that they notice and can strategize and use in what they're imagining is the universe. But again, it's of all the things I can fairly confidently say about the universe, it's really, really, really likely we can only literally see and even really strongly interact with a little part of it. That doesn't mean that it's like angels and demons and fucking souls flying around and all that in the larger universe, but rather it's like, oh, there's other possible crazy decompositions of the universal wave function that have like different physics and stuff. That's pretty exotic from a new age / paranormal perspective. Like, that's pretty exotic. It's pretty, I mean, that's far, far more likely than, you know what I mean?
No, it's far more likely.
It's far more likely that we're seeing effects of a larger wave function than it is we're seeing like angels and demons.
I tried to look and see if there were any experiments you can do yourself at home without having a scientific lab or special cameras or anything else. And the closest one I could find, I'm not really sure what it was, but you put your fingers together really close together and shine light through that. And if you see a band of light, not unlike an aura, that band of light is something having to do with quantum entanglement. Not understand it.
I actually did this once. Take a piece of paper or something very, very opaque, cut a hole in it or a slit or something, put it in a very dark room, shine a laser. I think the redder the better.
Okay.
Shine a laser through that hole, and you should see banding around the where the laser ends up on a far wall.
Oh.
So the farther the wall, the better. You should see, like, it's not just a point. There'll be circles of light around it. You do two, that's called the double slit experiment, and you'll see like interference patterns. There will be parts where it's totally black, where the light potentially should have been able to go, and that is an effect of the light going, essentially you can think of it multiple paths through the holes or the hole and interacting with itself.
Oh, that's so cool.
Because it's a wave, not a particle.
Truly Terrified is a Salt of the Earth production. Tell us your story and send us your comments. You can send us a 3-minute voicemail at 715-575-9420 or text us at that same number. You can also email us at lynnandjoeonthego@gmail.com or contact us through Reddit. Our contact information is also in the show notes. Please share, subscribe, and leave a review wherever you get your podcasts. Thanks for listening, and never be so terrified you can't run.
You can't run from yourself in a different universe.